G'day guys, how's this going? So in this video, we're just going to continue from the previous video and basically introduce some more methods on the string and slice types. And I think what we got to in the last video was the trim method. Well, trim has two other methods that are very similar to it, which is trim start and trim end. It's kind of similar to begins with and ends with, or starts with and ends with. You have a trim start and a trim end. So to demonstrate that, let's look at trim start first. So I'm just going to remove the space at the end here, and I'm going to bring down, well, no, let's keep the space on the end here. So instead of calling dot trim in this situation, we're going to call trim start, okay? So this will now just remove the beginning space, but not anything else. And I'm going to do that for the slice as well. And let's have a look at the result, right? So if we run this, what you should see is one character less this time, because now we're only trimming one side, which is the beginning. So the original size of the string was 14. When it's trimmed, it's now only 13, because it did the front, but not the end. Same with the slice. It started off with 7, but now it's reduced only to 6, because it's only trimmed off the beginning of that string. Got it? Now this is the same if we go trim end. So it'll go trim end and trim end. And if we run this, we're going to get the same numbers, but the difference is that you'll see that there's still kind of a space at the beginning of these words, right? Not the best or not the easiest to see in a console, but it definitely is there. Okay. So that's trim start and trim end. Now we have the parse method. So that looks very different. So I'm going to actually get rid of most of this code because we're not going to need it. And for parse, we're going to once again use options. And we're going to change the text here to 77. And we're just going to get just one of those items or one of those characters. So from 0 to 1. And in fact, I could say up and to 1 gives us the same thing. So one string will say 77. The slice will say just 7. Right? That's the point. They're both numbers. That's the point. But I'm going to make these a valid number string and valid number slice. And then I'm going to do something similar here where I'm going to have an invalid number string and an invalid number slice. And what this is going to have is just, I don't know, not a number. And this might go up a few more characters. Let's go 5, right? And what's going on here? Oh, silly me. Can't copy and paste properly either. Cool. So if I go if let okay, and I'll get to what that is in a second, valid number equals valid number string dot parse, right? So this parse method returns a result. And what you also want to do to make this better on yourself, because at the moment the type is unknown, we will use this special, what we call a generic, but I haven't got to that yet. And I'm going to define that this parse is looking for an unsigned 32 integer, right? So now this is an unsigned 32-bit integer. Cool. So by that, I can say, okay, if this was able to be parsed to an unsigned of type 32 bits, then we can basically go into this if block and handle it, right? Otherwise, we won't. So in this case, I'm just going to print out, whoops, went too far. print line, and I'm going to say valid number from string was, and I'm just going to put valid number here. Cool. Now I'm going to do this for the slice as well, because it's essentially the same logic, except the only difference is I'm going to be using valid number slice, and I'm going to rename this to slice. Cool. And now I'll take the same two if okay expressions, and I'm going to change it for the other two. So invalid number string and invalid number slice. Now, what's going to happen is when I run this, I'm only going to get two print statements that come out. Valid number from string was 77. Valid number from slice was 7. So that's actually triggering these two if conditions because they were able to be successfully parsed from what it is to a number. But not the number is not a number. So these last two don't parse. So if you want to handle the situation of what happens when you don't successfully parse, we've got an error result, and this will take in an error string or an error object. So this okayed error comes from the idea that a parse returns a result which is either the type as an okay, wrapped in an okay, right? Or it's going to return an ERR with the parse into error inside as an argument, right? So in this case, this is what will be returned for both of the bottom here. And then I just need to tweak the message. So we'll just type here invalid number from string gave error. And then I'm just going to copy that to the one below and then just say from slice. So now that we've handled the error cases for the ones that won't parse, we should get 4 outputs. There we go. And the error output says invalid digit found in string. So basically, as soon as it found a non-digit character, it fails. That's essentially what it's telling us, okay? So that's the parse function. So the next one I have in my list is the isASCII method. And this one is much more complicated than you think. So if you don't know what the ASCII character set is, it's essentially the default character set we had for a very long time before Unicode was a thing. And it was basically your standard English numbers, your standard English letters, and some other things like, exclamation marks, ampersands, equal signs, things like that, right? That was in our ASCII character set. So when we check a string in Rust, it's quite possible that we may have characters that aren't ASCII, and that's what this method is going to check for. So if I go back to letting a sum string equal string from, and let's use letters that are in the ASCII set for now. So hello world is definitely all in the ASCII character set. If I now do a test such as print line sum string is ASCII is equal to sum string dot string. Whoops. What have I got? Oh, sorry. Dot ASCII. Now, where is it? Is ASCII. Yeah, I thought it was that. Sorry, I had to just check. So let's get rid of that bit there. So what this is going to do is it's going to tell me it's true, right? It's going to tell me it's true because all these letters are part of the ASCII character set. But if we do something like grab the Greek alphabet. Let's say I'm just going to copy and paste some Greek here. So if I do this and I run it, well, it's going to say false because now we're using characters that are Unicode characters that aren't in the ASCII character set. Cool. Now this works for slices as well. So let's just quickly make sure that we prove that. Equals substring. And we'll go, I don't know, 0 to, let's go 0 to 5. Now keep in mind that the characters above could be more than 1 byte. So I'm trying to grab as many as I can. So I think I grabbed the first 2 characters in this set here by doing that. And you shouldn't really test it that way, but just to demonstrate this method, this is what I'm going to do. And you can see that that also returns false. But if I put this back to hello world, where it's going to grab the word hello, you'll see it's true again. Cool? So that proves how that works. Now, the next method I'll demonstrate quickly is the equals method. And that essentially compares 2 pieces of string. And I think it compares it only from an ASCII point of view. Right, so if I go substring, let's go left string, and then we'll have a right string, which is maybe, let's just change the capitalization here for a second, like so. So then we'll have a left slice, and then we'll also have a right slice, right? So what we'll do is we'll print out left string, right string. Let's just quickly change this side. Like so. How are we going for time? We're a little over, so I'll just demonstrate this one and then I'll finish the video. So left slice, right slice. So we can print those out too. Like so. Let's quickly run that just to see what we get. And there we go. So right string, that's not correct. Right slice is not correct, sorry, because I'm using left string. All right, so now we've got what we're after, right? So what I can do now is I can go left string equals right string. And here what I'm going to do is type left string. Oops, if I spell it right. Dot EQ equals, and you've got to give a reference to right string, because if you don't, you'll lose ownership. And then I'm going to do the same for the slices. So let's just go, oops, that should say left slice. I just realized. And right slice. Not ideal. And left slice is equal to right slice, right? So now if I, whoop, what have I done here? I don't need the @ symbol for slices because it's inferred that way. And there we go. So we got a left string, it says hello world here. Right string says hello world. Left string equals right string is false because the capitalization isn't the same. And as a result, so is left slice and right slice. That's also false because the capitalization isn't the same. But if I just change the first letter of right string, then we should see the slices match up. So I'll run it again. And now you can see the left and right slices are equal, but the left string and right string are not equal. So now let's set this to a capital W. Run that. And now that returns true. So the equals function takes into consideration casing. Okay. And that's where we're going to end this video. So I'll see you all in the very next one.